Okay, good evening. Shropshire Astro. Pleasure to be here. Having talked to you before by Zoom, it's nice to be here live. I'm Steve Barrett. I'm from the University of Liverpool. I'm a senior research fellow there. My research is involved in various aspects of imaging and in infrared spectroscopy, but I've always had a passion for astronomy. And this evening, I'm going to give you two short talks. The first one, Apollo 13, and then well, we'll see what the second one is after we've had a short break and perhaps a quick cup of tea. So this is Apollo 13. Hopefully, I'll say a few things that you may not know about from that particular mission. Perhaps you know everything there is to know about spaceflight. Perhaps you've all seen the film, the 1995 film with Tom Hanks describing the mission. So back in 1970, the Apollo 13 mission took off on top of the mighty Saturn V. Notice that the Saturn V has taken a few Apollo missions up previously, but not Apollo 9. Remember, Apollo 9 was simply taking spacecraft into Earth orbit to test them. 8 was a loop around the moon. 10 was a full dress rehearsal. 11, the first landing. 12, the second landing. So it was a spectacular launch, and on board should have been Ken Mattingly, Jim Lovell, and Fred Hayes, the original crew. But unfortunately, Ken Mattingly was exposed to German measles not long before the launch, and hence he had to be replaced essentially at the last minute with Jack Swigert. So the actual crew that went were these three, Swigert, Lovell, and Hayes. And the mission itself has been immortalized, well, more than once, but certainly it's been immortalized by Hollywood in the 1995 film. And I'm not going to go through all of the details of Apollo 13 because it's all on record, and even better, it's all in that film. And if you haven't been to see it, I suggest you do. If you're going to have a 1995 film and try and immortalize this particular event, who do you get? What actors do you get to play the three crew members? You pick the most famous astronaut that exists in 1995. And who's that? Yep, that's right. So the most famous astronaut in 1995. Toy Story came out in the same year. Therefore, you'd think that's the sort of person we want. But no, they went against the idea of having animation, and they went with three A-lister actors. Swigert was played by Kevin Bacon. Jim Lovell was played by Tom Hanks. And Fred Hayes at the end there was played by Bill Paxton. So, a great film, some great acting, very close to the truth as far as you can tell. If you look at the actual transcripts and the actual documentary evidence for what actually happened on the mission, the film was indeed very close. But perhaps, even if you've seen the film, you don't appreciate that the events of Apollo 13 back in 1970, the 1995 film, by the way, just to remind people, was the 25th anniversary of the actual event itself. The actual event in 1970, the film in 1995. But as well as the film, not many people realized that the events of Apollo 13 were immortalized not only on celluloid, but also in Lego, because they brought out this wonderful kit of 500 or so pieces. And the real heroes, the astronauts are of course heroes, but the real heroes are the mission controllers. And in this particular case, we've got astronauts, mission controllers, and the spacecraft itself. If we have a look at mission control, there's the part of the mission control desk at the front there, a big red phone. I presume that's to, I don't know, get hold of the president if you need them at the last minute. There's an Apollo 13 emergency plan sitting on the desk there. And perhaps even more importantly, there's a cup of coffee on the end, because they drank an awful lot of that during the 6 days of the crisis, or at least the 4 days of the crisis. The mission controllers themselves, there were obviously hundreds, if not thousands of them, and they're immortalized in Lego, not with 1,000 minifigures, but they've taken 3 representative figures. In the middle there, the flight director, Gene Kranz, with the buzz cut and the slightly stern expression, wearing the signature white vest as they call them in America, or waistcoat as we call them here in the UK. Flagged on either side by the people, the real heroes of the day, the dynamics officer, the engineers. You can tell they're engineers because they've either got a ruler or a slide rule in their pocket there, so they must be real people ready to roll their sleeves up and get the job done. So there's the mission controllers that effectively saved the mission. The astronauts themselves Well, we've got the three there, the commander, Jim Lovell, the lunar module pilot on the right, Fred Hayes, and on the left, Jack Swigert, the command module pilot. Now you see that Lovell looks happy enough, and Hayes, yeah, a little bit of a smirk on his face, but look at Swigert. Look at him on the left there. Swigert was in command, or at least in control, the pilot of the command module, and it was that part that had the problem. Houston, we've had a problem. So in a sense, Swigert had to deal with most of the problems that cropped up during the mission. So that's perhaps why LEGO decided to give him a little bit of an exasperated expression. Look at those eyebrows. He's clearly not a happy man. The actual LEGO model of the spacecraft itself is very crude by LEGO standards, simply because the scale in which they made it. So a rather crude lunar module at the end there and command and service module here. The problem arose on the Apollo 13 mission because of an explosion here in the service module. So the LEGO comes in two bits, the pre-explosion version and the post-explosion version, where the side of the service module has been blown off and exposing some of the damage that was caused at the time. That particular LEGO model, nowhere near as nice, if you like, as other LEGO models. This one is on a different scale, and hence there's much more detail. This is the 50th anniversary of the Apollo 11 moon landing, and again, you see more detail in the lunar lander. But the scale of the previous model simply limits how much you can get in there. So just to make sure we're all aware of the various little acronyms and abbreviations that have already cropped up and will crop up again in this short talk, there's a schematic of the Apollo spacecraft on its way to the moon. And the left-hand part, the cylindrical part, is the service module. This provides services to the astronauts. It provides them with water, provides them with oxygen, provides them with power. And it's also got the fuel for the main engine at the back there that provides the principal propulsion of the Apollo spacecraft. In the middle, the conical section is the command module, where the three crew are for launch and eventually coming back to Earth. And on the right-hand side there, we have the lunar module. So the normal abbreviations are, we refer to the service module, not surprisingly, as the SM, the command module, CM, and the lunar module as LM. But because the command module is basically serviced by the service module for essentially the whole of the mission, these two on the left stay docked together for almost 99% of the mission, and therefore they're often classified as a single spacecraft, the CSM, the command and service module. Again, no real imagination required there. So those are the abbreviations that will crop up from time to time. So let's remind ourselves, before we talk about what went wrong, let's just describe what a normal mission should actually look like. And again, we're going to use the medium of LEGO to tell the story. So the Saturn V gets the spacecraft into orbit, and then the last stage of the Saturn V sends them on the way to the moon. We won't bother about all of those details. That all worked fine. And it takes 3 days to get the spacecraft to the moon. In other words, they go fast enough on leaving Earth orbit such that they effectively coast to the moon in 3 days. When they get to the moon, the idea is that the three crew will not live all of their life in the command module there. Once they're ready to go down to the moon, 2 of the astronauts, in this case Lovell and Hayes, will move into the lunar module, prep it for landing, and then when everything is okay, Swigert will stay in the command module, Lovell and Hayes will be in the lunar module. They'll then seal off the docking tunnel that links the two together so that they now have 2 separate spacecraft, and the lunar module will go down to the lunar surface. Now, of course, the astronauts are inside. They're not hanging onto the leg, as this particular animation would imply, hanging on for dear life as the lunar module goes down. I just couldn't animate them going inside and coming out again. So they go down to the surface. The 2 astronauts do their stuff, which involves planting a flag, picking up a few rock samples, doing a few experiments, etc. And once they are done, they get back into the lunar module, but the whole lot doesn't come back into orbit to dock with or redock with the spacecraft that's been in lunar orbit for the last few days. There's no need to bring the descent stage which brought them down. That's just dead weight, effectively. So only the ascent stage, the top half, blasts off, goes back into lunar orbit, and then docks with the original command module, where hopefully Swigert has been skillfully piloting it, and then dock the spacecraft together. So essentially, these descent modules, these descent stages of the lunar modules are dotted around the moon because once they're down, they stay down. Once we're back in lunar orbit again, the two astronauts that were in the lunar module, the two moonwalkers, go back into the command module. So now they're all three reunited again. Now that they are reunited, the ascent module, the ascent stage of the lunar module has no purpose anymore. There's no point in dragging it back to the Earth because that uses fuel. So they jettison it at this point, and the ascent module either goes off and goes into orbit around the sun, or in orbit around the moon, or crashes into the moon, depending on which particular Apollo mission we're dealing with. Now that all of that is done, the three astronauts in the command module make their way back to Earth. Takes another 3 days to get back to Earth. And once they are getting close to Earth, coming in at a rate of speed, again, when they're close enough, only perhaps an hour or two away from Earth, they have no further use of the service module. That's done its job of providing them with oxygen and water and power and fuel for the motor. All of that is now no longer necessary, so the service module is jettisoned, is no longer required, and the three astronauts are left alone in the command module, the conical command module, with essentially no external propulsion, but a heat shield such that when they enter the Earth's atmosphere, they're protected, and then they splash down in the Pacific Ocean. There it goes, splash, you see. So, okay, that's not the Pacific Ocean, I realize that. I could have chosen a different picture of the Earth. They didn't actually land in the Indian, they did land in the Pacific, but that's just a nicer picture of Earth there, that's all. So that's how the mission is supposed to go. So how was it different? What actually happened in Apollo 13? Launch, everything else went exactly as planned. On the 3-day trip to the moon, something went wrong. Approximately 2 days out was the famous bang, Houston, we've had a problem. They did not know what the problem was. They only knew it was really serious because they heard a big bang. The spacecraft started lurching backwards and forwards, and all the indicators indicated they were losing oxygen, they were losing power. This is really serious when you're on a spacecraft halfway between the Earth and the moon. They didn't know it at the time because they couldn't see what was going on. None of the windows in the command or the lunar module allow them to see what's going on in the service module. Later in the mission, they found out that the entire side of the spacecraft had blown out. But they were relying on their instruments to tell them what was going on. Same for mission control. They couldn't see what was happening. They were relying on what is the power doing, what's the water doing, what's the oxygen levels doing, to try and work out what was actually going wrong. What actually happened, again, they didn't figure this out until afterwards. What actually happened was there was an oxygen tank in this part of the spacecraft. They need to be stirred every once in a while to keep the cryogenic liquids inside nicely uniform and homogeneous. They didn't realize there was a faulty insulation on a fan that does the stirring. When they switched the fan on, there was a spark. A spark in an oxygen tank is not a good idea. The oxygen tank blew up and it took the side of the spacecraft out. And most importantly, it took out one and then the other fuel cell. And the fuel cells are responsible for providing the spacecraft with power. As soon as they realized they'd lost the fuel cells, they knew they'd lost the mission. If you take out the fuel cells, you do not have enough power to do anything. Even if nothing else went wrong, that was the end of the mission. So the question is, what do you then do? Both the astronauts and the mission controllers very quickly figured out the service module can no longer provide water and oxygen and power to the astronauts. They realized that the lunar module is an entirely independent spacecraft. It happens to be docked at the moment, but it's an independent spacecraft, so it has its own power systems. It can, in principle, produce the life support they need. So they realized that what they had to do was move from the dead spacecraft into the lifeboat of the lunar module, which hopefully could keep them alive. The only way they could survive is to say, we're going to have to power down everything on the other side. We're going to have to power down the command module and the service module, which were never designed to be powered down. They're designed basically to be operational for the entire mission. But that was a decision they simply had to make. How do they figure out what to do next? Well, they already had a contingency plan. This is NASA, so they try and plan for the worst. And when they plan for the worst, they basically plan for, what if we get to the moon and then we have a problem, how do we get home? In other words, how do we make our astronauts survive a 3-day trip back from the moon if one of our spacecraft is crippled? The catch is, although they'd thought of that scenario, they're not 3 days from home, they're 2 days out. One option is to say, right, we stop, turn around and go home again. But remember, they're going at sort of, 25,000 miles an hour in that direction. Stopping, turning around and going back again is possible if you fire the engine. But remember the amount of damage that's been done to the service module. Who knows what other damage has been done that they don't necessarily know about? Maybe firing the propulsion system would just make matters worse. So they decided not to risk turning around and coming home. They said, we're 2 days out, we've got another day to get to the moon, and then 3 days to get to home. We know how to survive for 3 days. Can we survive for 4 days with a crippled spacecraft? They decided that was the only real option. So they carried on to the moon, went round the back of the moon, and came round and basically tried to get home as quickly as possible, with a little assistance from the lunar module engine, which was fine because there was no damage to that. So the problem is, how do they ensure that they can survive for 4 days with a crippled spacecraft? And that is a lot of what the 1995 film is about the interplay between the astronauts in the craft and the mission controllers trying to figure out how to keep these people alive. The bottom line is they had enough food, because the food is on board and the food is fine. They had to be careful with how much water they drank. They had to take the power levels down to 0, which means the spacecraft got extremely cold. They had to take it as cold as they could go without getting complete hypothermia. And they had to worry about the fact that although in principle they had some oxygen, they had to worry about the fact that, for instance, this lunar module on the right-hand side is designed to accommodate 2 astronauts for 2 days, because that's what normally happens. They go in there, the 2 of them, they go down to the moon, 2 days later they're back, and then the lunar module has done its job. So all of its systems were designed to keep 2 people alive for 2 days. But now it's got 3 people in there, and we've got to keep them alive for 4 days. And the problem is the carbon dioxide is going to start building up, because they are no longer where they should be, in the sense that Swygut should be in the command module, and they shouldn't be in the lunar module for that long. So carbon dioxide started building up, and they started having to be rather resourceful as to how they dealt with that, because the carbon dioxide scrubbers in one craft did not fit the carbon dioxide scrubbers in the other craft. One was built by one company, and another was built by another company, and they were not compatible. They had never conceived of the possibility that maybe the carbon dioxide would build up in one craft because of the other one being crippled, and wouldn't it be a good idea if all the systems were cross-compatible? That would have taken longer, it would have been more expensive. In hindsight, it's very easy to say, why didn't they do that? But at the time, they never figured that would be a scenario they would have to deal with. So, long story short, they had a very uncomfortable 4 days where they had to take the power levels down to 0, be careful with the water they drank, and be rather resourceful as to how they dealt with the carbon dioxide levels that started to build up. Again, all of that is documented very well on the NASA web pages and in the film itself. So they had to go into survival mode. It was certainly not very comfortable for them. But after 4 days, they were still alive, and they were heading back to Earth. Once they got close to Earth, they realized that this, given that the service module wasn't really doing much, in the sense it wasn't really servicing their needs, and they weren't going to use the propulsion, they decided that move back into the command module and jettison the service module, which is no longer of any use to us. Now you end up with a spacecraft in a configuration that was never actually designed for. There was never supposed to be a situation where the command module was still docked to the lunar module as it was heading back to Earth. But at this point, once the service module was jettisoned, that's the first time they actually got sight of what the problem was. That's when this particular picture was taken, just after the service module was jettisoned, hence no command module on the end there. And that's when they got first sight of the damage and thought to themselves, yeah, it probably was a good idea that we didn't try to fire that engine, because it could easily have caused us more problems than we could appreciate at the time. So now they say, right, we're heading towards Earth. We still really need the power that's in the lunar module. The lunar module has got its own power systems, its own batteries, but they really had to be very careful as to how they brought the command module back up again. Remember, it's been dead for 4 days. It's been dead for 4 days with zero power. It's extremely cold in there, and they are still breathing in and out, and there's still water vapor around, which means water is condensing on all of the electrical circuits in the command module. And they want to boot it back up again because it has to be live for them to come back to Earth. So they have to worry about the fact they're now putting live electricity back in a system which appears to be half waterlogged because it's been essentially at freezing temperatures for the last 4 days. And there's a limited amount of power from the lunar module. They had to very carefully decide what power are we going to take from the lunar module and put into the command module to try and get the systems back up again. Only the bare essential systems, no luxuries. Hence, people on Earth in mission control running the simulators try to simulate what needs to be done to make sure that this is done in the right order to get the power where we need it. By the way, it's a good idea if we reserve just enough power to warm those parachutes up. The parachutes in the command module are eventually going to slow them down as they come through the Earth's atmosphere. If those 3 parachutes are still blocks of ice when they come in, they are not going to slow down. So it's a good idea to try and heat those up so that they are operational once they arrive back at Earth. They got it right, they got the power systems back up, they rebooted the command module, and then once they were happy that they'd taken all the power out of the lunar module that they could possibly take, they then set it loose. The call sign for the lunar module was Aquarius. Once they were done with it, farewell Aquarius, we thank you. So now they're in the lunar module, they're ready to come home. They just hope that the heat shield wasn't damaged by the explosion. Didn't look like it was, but how can you tell? And they really, really hope the parachutes have thawed out by now as they come into Earth, through the Earth's atmosphere, splash down in the Pacific. And yes, everything worked. Everything was okay. Mission Control did its job wonderfully and got them home alive. In the film, Ed Harris, who plays the mission flight director, Gene Kranz, said, "Failure is not an option." Gene Kranz actually never said that, according to his autobiography. What he said was something like, "These astronauts are in trouble. It's our job to get them home. We have lots of options, but failure is not one of them." That's a bit catchier. So the film director, Ron Howard, took that sentiment that Gene Kranz had said and just condensed it down to a neater soundbite, as it were. So that got a lot of recognition at the time. Failure is not an option became a sort of catchphrase for the film. And indeed, Gene Kranz himself wrote an autobiography afterwards and used it, even though he never said it, he used it as the title of his book because he figured that it did so succinctly summarize the feelings of everybody in Mission Control that they could not fail in getting these 3 astronauts home. The command module itself, his call sign Odyssey, made its way safely back to Earth with the 3 occupants. But what about the rest of the Apollo hardware? Well, the 4th stage of the Saturn V is responsible for getting them to the moon. Once they have released from the Saturn V 4th stage, that's still moving with them. It's still moving with them in the same direction at approximately the same speed. And one option is just to send it veering off at an angle and send it off around the sun. But in this case, they decided that the 3rd stage of the Saturn V rocket had one more job to do, which seemed like a good idea at the time. They sent it crashing into the moon. That meant that they had a rocket with a known mass moving at a known velocity, hitting the moon in a known place, which allowed them to calibrate the seismometers that they'd left on the previous mission. Apollo 12 had a seismometer on the surface of the moon, so by crashing in an object at a different position, they could see how the surface of the moon reacted and how the surface of the moon vibrated. It rang like a bell for a little while, but it was a useful thing to do because otherwise the rocket stage is of no use, so you may as well actually use it to calibrate some scientific instruments. What about the lunar module? The lunar module Aquarius, I showed you just a moment ago that it was jettisoned just before they re-entered, and remember it's only the command module that's built to re-enter the Earth's atmosphere. The lunar module was only ever designed to work in the vacuum of space or on the surface of the moon. The lunar module is far too fragile to come into the Earth's atmosphere. But when it did come into the Earth's atmosphere, they didn't just say, no problem, it'll disintegrate. They had to be very careful as to where they brought it down. It was vital that they brought it down somewhere that they could control. And what they really wanted to do was bring it down in the deepest part of the South Pacific. And there's a reason why they were so fanatical about wanting it to come down there. It wasn't that they were worried about bits of it raining down on the odd individual. They were worried about one particular component of a lunar module that should never come back to Earth because it's designed not to. And that is a cask of plutonium, which sits in the descent stage. Here on the previous mission, Alan Bean from Apollo 12 is taking the plutonium out of the descent stage of the lunar module. It goes into this device by his feet, which is called an RTG, a radioisotope thermoelectric generator. Basically, plutonium gets hot and you can use that to generate energy. This is the thing that powers all of the scientific instruments on the surface of the moon. You could, if you wish, use solar panels, but then solar panels during the night, of course, you have 2 weeks of nighttime on the moon, and so the scientific experiments would go dead. Not a good idea. So to keep all of the instruments running, they use plutonium. It's got a half-life of about 80 or so years. That means that these instruments, in principle, can run for decades quite happily. But given that this is supposed to stay on the moon and run the experiments, it is not supposed to come back. All of the other descent stages and all the other equipment, of course, are still sitting where they were left. But in Apollo 13, the lunar module came back to Earth. So they wanted to be absolutely sure that the plutonium went somewhere safe. And they basically designed it to go down into the Tonga Trench of the South Pacific. They've been monitoring the radiation levels ever since and have not seen the slightest increase. So it looks like the cask survived the re-entry, which it was designed to do effectively, and there's been no sign of any leakage. So it's down there 10,000 meters deep or thereabouts. At the end of the film, the actor Tom Hanks, playing Jim Lovell, shakes hands with the captain of the USS Iwo Jima, the ship that picks them up. Who actually plays the captain? Jim Lovell himself. So this is Jim Lovell shaking hands with Jim Lovell, in a sense. A nice touch, I thought. Jim Lovell himself, when he came back to the USS Iwo Jima, the first thing he did was read the papers and learn what had been happening for the last 6 days. Of course, the public was gripped by the whole drama. The mission controllers and the astronauts weren't discussing it. They were discussing how do we get out of this problem. They didn't perhaps realize that the entire world was behind them in terms of wishing them the best luck for a safe return. So not only is Jim Lovell reading the papers to try and catch up on the news, I noticed that somebody, I don't know who that is on the left-hand side, is already at work signing the publicity photos to give out when they get back to civilization. The next particular little anecdote depends on knowing who built what. When we think about this, remember Apollo was a very big project. You can't get one aerospace manufacturer to build everything. Part of the Saturn V was built by Boeing. Part of the Saturn V was built by McDonnell Douglas. In terms of the Apollo spacecraft, the command and service modules were built by one company and the lunar module was built by a different company. That's one of the reasons that you have this problem with the CO2 scrubbers being different between the two spacecraft. North American Rockwell built the command and service modules and Grumman Aerospace built the lunar module. So because the problem occurred within the service module, the explosion was in the service module, and because they used the lunar module as a lifeboat, Grumman thought to themselves, well, not the bosses of Grumman, but the technicians and the engineers of Grumman said to themselves, hang on a minute, we have saved the mission. Grumman saved North American Rockwell. The problem was on North American Rockwell's side. Grumman came to the rescue. So the engineers of Grumman Aerospace said, I've got an idea. Why don't we invoice them and give them a bill for our services? So they actually invented an invoice. None of the people at the top knew about this, apparently. It was sent from the engineers of one to the engineers of another. And I'm sure you can't read that. So it's basically an invoice which is going to Houston via the USS Iwo Jima, because they knew that's where the astronauts would be. And they've been charged, the Grumman Aircraft Engineering Corporation are charging North American Rockwell for the following services. One, a towing bill. $4 for the first mile and $1 for each additional mile. And they traveled about 400,000 miles or so that adds up to something like $400,000 for the towing bill. The lunar module also provided power to the command module, so they charge them also for a battery charge. Okay, the customer provided the jump cables, but basically the Grumman were providing the power to North American Rockwell. So there's a battery charge in there as well. But the one I quite like is the fact that the three people were in the lunar module where they shouldn't be. So they charged them basically a sleeping accommodation bill. Now, sleeping accommodation for two with the usual caveat, okay, no TV, air conditioned, but there is a radio and a hell of a view. That's fantastic, yep. But of course, that's part of the normal mission because there should be two people in the lunar module. Therefore, that's prepaid. That's not something they are billing them for because that's the mission plan. But the mission plan wasn't to have three people in the lunar module. Hence, the invoice includes additional guest in room at a cost of $8 a night. So instead of $400,000, it's now $400,000 and a bit for the extra $8 per night. I presume $8 is probably the standard motel bill at that time of the decade, as it were, that time of the century. There's a few other minor things like water and other things, and there's no tax applied because it's a government contract. They also have a deduction there for fast payment, I think, as well. But the bottom line is they were charged $312,000. I believe it was never paid because North American basically said, yeah, but on all other missions, North America has done the towing and the lunar module is along for the ride, so it all cancels out. But it's a nice bit of humor on the part of the engineers to actually think about invoicing for saving the mission. As a point of epilogue, when command modules come back to Earth, they look a little bit like that. They look a bit crispy at the edges, a little bit charred, because they've come through the atmosphere, and the heat shield has been mainly eaten away. It's survived on all of the command modules, but yes, the heat shield gets ablated during re-entry, and you can see thermal shielding, which looks a little bit sort of like gold foil in this particular case. It's sort of a little bit like gold or silver foil. It's a mylar thermal shielding, some of which gets completely stripped away as it comes through the atmosphere. But some of it usually survives. Before it goes into a museum, the command modules are always cleaned up. So basically, they take the command module, they strip all the messy-looking thermal shielding off, and then they put the command module, after making it safe, of course, they put the command module then into a museum. This particular one is in a museum, I believe, somewhere in Kansas. But the point is, what do you do with all this mylar? One option is chuck it in the bin. But somebody said, well, aren't people interested in memorabilia? Why don't we give it to museums? And museums can take chunks of this stuff, cut it up into tiny pieces, and sell it to gullible individuals who want to buy a small piece of Apollo 13. One such gullible individual is me. So sitting here right in the middle is a tiny piece of Apollo 13. A little bit of history. Costs a few dollars, and of course they're making a hell of a profit because they've taken scrap material and are selling it for a few dollars per square millimeter to thousands of people. But it's nice to own a little bit of history. Final epilogue, 45-year anniversary of Apollo 13. A lineup of some amazing people. On the left, Charlie Duke, and then we've got Lovell and Hayes. Unfortunately, Swigert died sometime after Apollo 13. He died of cancer before he went into intending to go into a career of politics. So we have the original astronauts, Lovell and Hayes, and then we have Krantz himself, one of the prime mission directors, and other mission directors such as Lunny and Griffin, and then other astronauts, Brand, Loosma, and Kerwin. So a hell of a lineup of individuals. Last time I checked, all of these people were still alive, quite amazingly enough. They're all in their 80s or 90s, of course, because we're talking about an event that occurred in 1970. And it got me thinking that basically we, humanity, is going back to the moon. I wonder how long before we see another lineup like this. It was thought of at the time perhaps as a disaster, but Krantz said this was NASA's finest hour. Thank you for listening.